Hello and welcome to the live session by Infinity learned by Sri Chaitanya. I am Misbah, your maths educator, and in this class we are going to do the fundamental theorem of arithmetic. That is the very first topic in your syllabus in grade 10. So before starting with fundamental theorem of arithmetic, we'll first be revising the types of numbers which you have done up till now. Hello English Antibiotic, hi Javed, hello Mohit, welcome to this session. Are you guys able to hear and see me properly? Just comment in the chat quickly so that we can start with the class. So this is the very first session in mathematics in Pioneer series on the Infinity Learn class 9 and 10 YouTube channel, wherein we are going to do the whole syllabus of grade 10 mathematics. Obviously, we'll be covering CBSE grade 10 maths and much more than that as well. Hello Anshul, welcome to this session. So let's wait for some more seconds. Let other students join as well, and then we'll be going to start with the class. Hello Anshul, welcome to this session. Okay, so let's start with the class guys over here. So before actually starting with the topics, the fundamental theorem of arithmetic, we'll just revise the type of numbers which you have studied up till now in grade 10. Obviously, some other types of numbers are there as well, but most of the types I'm covering over here. So the first thing is natural numbers. So what are natural numbers? Can you comment in the chat over here? Hi Saurabh, welcome to this session. What are natural numbers? You have been studying about natural numbers since childhood, right? So what are natural numbers, guys? So natural numbers are counting numbers, right? Counting numbers are called natural numbers. That is 1, 2, 3, 4 and so on. Counting numbers are called natural numbers. The collection, this set of all natural numbers is represented by capital N. Counting numbers exactly are called natural numbers, and the set of all natural numbers is represented by capital N. Now 0 and then the natural numbers. Natural numbers including 0, they are known as this set of all whole numbers, right? Set of all whole numbers, the collection of all whole numbers is represented by W normally. I hope it is clear. Hi Karthik, welcome to this session. Exactly Saurav, exactly swap, very basic concept it is. Now you have also studied integers. So basically all the negative integers you have got -3, -2, -1 and then 0 over here, and then all natural numbers. So all of them are collectively known as integers, and the collection of all integers is represented by Z, and Z comes from the Greek word Zahlen. It comes from the, not Greek word, German word Zahlen. I don't know how to pronounce it because obviously it is in German and I don't know German, right? So it means to count. It means to count. So positive integers many a times you represent by Z positive, and negative integers you represent by Z negative. I hope these things are clear to you. Exactly. 0 is also counted, swap. 0 is also an integer. 0 is also an integer, right? Okay, are you talking about why 0 is not a natural number? Because 0 is included later on, right? 0 was discovered. Because when you count something, you don't say 0 something, right? When you count, you understand it very basic logic. You can understand it like this. When you count something, you say it is 1, 2, 3, 4 or 5, right? You don't say this 0 something is there or -8 something is there, right? I hope it is clear. Exactly, Karthik. So whole numbers plus negative integers, they are collectively known as the set of all integers, which is represented by Z over here. I hope it is clear to everybody. Saurav, Swap, Karthik. Is it clear? Any doubt in that, Anshul? Okay, so let's move on to the next slide over here. Next other type of numbers which you have already seen. So rational numbers over here. So the collection of all numbers which can be represented in the form of P by Q, where P and Q are integers. So you write it like this: P and Q are integers. So they belong to Z. Integers belong to you represent by this sign epsilon. So P and Q are integers and Q is not equal to 0. I hope it is clear. So that is the definition of rational numbers. So basically you see over here all natural numbers are rational numbers because every natural number can be represented as a ratio of two integers. For example, 2 can be written as 2 by 1, 3 can be written as 3 by 1, 100 can be written as 100 by 1. So every natural number is a special type of a rational number, is a type of rational number. All whole numbers are rational numbers because in all whole number you see you can write it divided by 1. So 0 is also a rational number. All integers are rational numbers because in all of them you can write divided by 1, divided by 1, divided by 1. I hope it is clear. Fractions, you can see when you understand the fraction is basically all fractions are rational numbers only, na. Fractions you take the name fraction when you talk a part of something, you got it. Fraction, you don't use the concept of fraction when you're talking about types of numbers. I hope you understand that, na. Fraction is when you talk in terms of part of something, you got it or not. For example, 3 by 8, so 3 parts out of 8 equal parts, you got it. That is the meaning of fraction. That is not compulsory, Saurav. I hope you understand that. P and Q must be co-primes, that is not compulsory. For example, 3 by 6 is also a rational number. You don't need to simplify it, right? I hope it is okay with you. It is not compulsory for the numerator and the denominator to be co-prime numbers. It is not compulsory. I hope it is clear, Swap. Right? So basically all fractions are rational numbers only. Now over here, irrational numbers. So, okay, and one more thing, all rational numbers, the collection of all rational numbers is represented by Q. Q is coming from basically quotient, right? Quotient. So basically rational number you are representing as a quotient of two integers. I mean you are dividing one integer by another integer, right? So rational is coming from the word ratio only, ratio of two integers. So any number which can be represented as a ratio of two integers where denominator is not equal to 0 is a rational number. So therefore we represent the collection of all rational numbers by capital Q, which comes from the word quotient over here. I hope it is clear to you, right? Now what are irrational numbers? Numbers which cannot be written as a ratio of two integers, they are known as irrational numbers. For example, root 2. Even if you write root 2 upon 1, this is not a rational number because it cannot be represented as a ratio of two integers. So root 2 is not a rational number, it is an irrational number. In fact, you see pi is an irrational number. Pi is not equal to 22 upon 7. 22 upon 7 is just an approximate value of pi for calculative purposes. Pi is not equal to 3.14 or 3.143 you might be thinking of. These are just approximate values of pi for calculative purposes. Nobody in this world can ever find the exact value of pi or the exact value of any rational number, irrational number. I hope that is clear. Exactly, the word irrational is coming that because you cannot represent it as a ratio of two integers. That's it. Yes, there is something called Euler's number and there is something called this is called golden ratio. So there are many irrational numbers, right? Infinite type of irrational numbers are there. There are types of irrational numbers as well, algebraic irrational numbers and transcendental irrational numbers. So I am not going into that. I hope you understand that. There are basically largely two types of irrational numbers. One is algebraic irrational numbers and the other is transcendental irrational numbers. Algebraic irrational numbers are roots of equations, right? And having rational coefficients. I hope you understand that. Rational or whatever it is, I mean they are roots over here, and transcendental irrational numbers are these. These are transcendental irrational numbers. I hope that is clear to you, right? Okay. So I hope the definition of rational and irrational numbers is clear to you up till here. Now I am not talking about the decimal representation of them because that is not needed. What is needed, I am explaining that right now over here. Otherwise you know the decimal representation as well. For example, the decimal representation of rational can be terminating or non-terminating but recurring. Yes or no? Two types of decimal representation are there of rational numbers. They can be terminating decimal representation, they can have terminating decimal representation, or they can have non-terminating but repeating or recurring decimal representation, right? I'll explain that, Swap. I hope you understand that, right? So for example, you take 0.56, this is a terminating decimal representation because it is stopping after some place of decimal. So you can represent it in the form of p by q, where p and q are integers and q is not equal to 0. Now if you have got something like this, you must have studied that in grade 9. This is basically 1 only, right? So this can be represented in the form of p by q, where p and q are integers and q is not equal to 0. So for example, you have got 1.52 and a bar over it. So you must have studied a shortcut over here, right? You must have studied that it will be something like this, 152 minus the number on which bar is not there divided by, on 1 digit bar is there, so 1 time 9 will come, and on 1 digit bar is not there after the decimal, so 90. So this is the P by Q form. So whether it is terminating or non-terminating repeating number, then it's a rational number. Is it clear to everybody over here? Any doubt in that? Tell me. I hope it is clear, guys. Right. Now irrational numbers, I had taken some example. Now one student is asking surds. So basically surds, they are irrational numbers only. For example, you take this root 2. So this is an irrational number because you cannot find its square root, right? Now for example, because 2 is not a perfect square, you got it? Swap, 2 is not a perfect square. Now for example, you can take it like this. Suppose I am finding cube root of 3. This is also a surd. The reason being 3 is not a perfect cube. You got it? But suppose in place of this I am taking 27. This is not a surd because this will give you 3. Because 27 is a perfect cube. You got it? Now for example, I am taking 4th root of 10. This is a surd because 10 is not 4th power of an integer over here. You got it? But over here if you take 4th root of 16, so that will give you 2. I am not talking about negative and positive values over here. I hope it is clear. So therefore this is also a surd. Now they can be combined as well. For example, if I take multiply 3 over here, then also this is a surd. I can add 8 over here, then also this is a surd. In the same manner, if I multiply by, this is not a surd. If I multiply by, suppose I take this one, cube root of 3 over here, right? If I multiply by 5 over here and I add 7 over here, then also this is a surd. I hope it is clear. I hope the definition of surd is clear. Many a times it is asked. So I hope it is clear. Now over here you have got prime numbers. So numbers having only 2 factors, 1 and itself, they are called prime numbers. For example, 2 is a prime number, 3 is a prime number, 5 is a prime number. They are having only 2 factors, so therefore they are prime numbers. Numbers having 2 factors only are called prime numbers. I hope this is clear to every student over here in the session. Tell me. Now the question is 1 a prime number? Now after prime numbers you have got composite numbers. Numbers having more than 2 factors are called composite numbers. For example, 4 is a composite number because 1, 2 and 4, they are having more than 2 factors. It's having more than 2 factors. 9 is a composite number because it's having more than 2 factors, right? So numbers having more than 2 factors are called composite numbers. Numbers having only 2 factors are called prime numbers. No, it is not like that, swap. It is not like that. For example, see, if you have got square root of 4, it will be every time 2 only. You cannot say it is plus minus 2, it will be wrong. You got it? So basically, if you have got something like this, x is equal to 4, then it will be having 2 roots because you can write it like this. See, the reason being you can write it like this. I hope it is clear, swap. You can write it like this, so you can understand that it will have 2 roots over here. You can use a plus b, a minus b formula over here. X plus 2, x minus 2, that is equal to 0. So therefore from here it's having 2 roots. That is x plus minus 2. I hope it is clear. So basically square root of 4 is different from x square is equal to 4. This will have only one value over here if you are talking about real. We are talking in terms of positive numbers only, Saurabh. I hope it is clear. I hope that is clear to everybody in this session. And one more thing is there, swap. If you have got something like this square root of x square, that is every time a positive number. That is modulus of x, right? It can never be negative. I hope that is clear. Right? So composite numbers is clear. Now there is one more thing. 1 is neither prime nor composite. 1 is neither prime nor composite because it's having only one factor, that is 1 itself. Now you have got even numbers, so numbers which are divisible by 2, 2, 4, 6, 8 and all that, they are called even numbers over here, right? Now what is the smallest even prime number? Can you tell that? What is the even prime number? Can you tell that? Not smallest. What is even prime number? So 2 is the only even prime number. You got it? 2 is the only even prime number. Apart from that, every even number is not prime. 2 is the only even prime number. I hope it is clear to everybody in this session. Now there is something called co-prime numbers or relatively prime numbers. So obviously when you are using the word relative, it means you are talking about two things. So co-prime numbers or relatively prime numbers are numbers having HCF 1. For example, you take 3 and 7, they are co-prime numbers because their HCF is 1, or you can say there is no common factor between them except 1. There is no common factor between them except 1. So they are relatively prime numbers or co-prime numbers. For example, 3 and 8 are also co-prime numbers because there is no common factor between them except 1. So they are relatively prime numbers or co-prime numbers. So any doubt in these concepts to any student in this session, and any doubt in this part of it which I was explaining, tell me. This is different. Square root of 4 is not same as x square is equal to 4. This will have two solutions. It will give you only one value, and square root of x square is equal to modulus of x. Okay, this can be used many a times. You will do questions like that. I hope it is clear to you. See over here, swap. For example, you have got x square is equal to, for a simple example I am taking, because I am comparing root of, because I was comparing square root of 4. Square root of 4 will be 2 only, it will not be plus minus 2. But if you have got x square is equal to 4, can I take 4 on the other side of this equation? Now in place of 4, can I write 2 square over here? Now can I use a square minus b square formula? So that will be a plus b, a minus b. So therefore you see this will have two roots or not, plus minus 2. Is it clear now, swap? So you see this will be having two roots, therefore it's a quadratic equation. I hope it is clear. So 2-degree equation, so it can have two roots over here. But every time it will not have two roots. It's not that every quadratic equation will be having two real roots I am talking about. For example, if you have got x square plus 2 is equal to 0, so it will not have real roots, right? It will not have real roots. It will have something called complex or imaginary roots. I hope it is clear to you. The difference between x square is equal to 4 and square root of 4. I hope that is clear, right? So let's move on to the next thing, guys. Other things are twin prime numbers. Twin prime numbers are prime numbers whose difference is 2. For example, 3 and 5, they are twin prime numbers because their difference is 2. For example, 5 and 7 are twin prime numbers because their difference is 2. For example, 11 and 13 are twin prime numbers because their difference is 2. In the same manner, pair of prime numbers whose difference is 2, therefore they are twin prime numbers. No, two roots, that is not the reason. Two roots every time it will have. Quadratic equations will have two roots, whether rational, whether real or imaginary. That is not like that, swap. You got it, swap? Whether real or imaginary, a quadratic equation will every time have two roots. You got it? So whether it is real or imaginary, that is different discussion, right? You got it or not? A quadratic equation will have two roots. I was explaining this thing. The difference between this, basically many a time students say that it is equal to plus minus 2 na. So this will not be equal to plus minus 2. When you have got x square is equal to 4, basically when you have got x square is equal to 4, and from here if you are finding the value of x, then it will be plus minus 2. I was basically explaining that thing. I hope it is clear, swap. You got the difference or not? Okay, swap. I hope it is clear. Yes, 2 is a rational number which is a prime, Saurav. 2 is a rational number which is a prime. Every prime number is a rational number, na, because you can write it as a ratio of two integers. You got it? 3 is also a rational number. It is a prime number and a rational number both. I hope it is clear, right? So I hope co-prime numbers and relatively prime numbers, they are same. Two numbers whose HCF is 1, they are known as co-prime numbers. I mean, in which though no common factor except 1 is there. I hope it is clear to you. Now there is one more thing over here. Okay, twin prime numbers I had already discussed. Pair of prime numbers whose difference is 2, they are known as twin prime numbers. Pair of prime numbers whose difference is 2, they are known as twin prime numbers. Now there are perfect numbers. Perfect number is 6. For example, 6 is a perfect number. So can you tell me its divisors 1, 2, 3 and 6. So basically divisors are these, but except 6. Except the number itself, these are known as proper divisors. You got it? If you take a number and if you exclude the number itself, because every number is a divisor of itself, these are known as proper divisors. 1, 2, 3, they are proper divisors of 6. So you see over here, 6 is equal to sum of its proper divisors. You got it? 6 is equal to sum of its proper divisors, so therefore 6 is a perfect number. In the same manner, I think 28, yeah, 28 is a perfect number as well. Can you tell its factors? Its factors are 1, 2, 4, 7, 14, 28, right? But what are its proper divisors? Proper divisors are 1, 2, 4, 7 and 14. What is this sum of the proper divisors of 28? So are you getting 28 over here? Yeah, you will get 28 only. So a number which is equal to sum of its proper divisors is called a perfect number. Twin prime numbers are prime numbers whose difference is 2. For example, 3 and 5, 5 and 7, 11 and 13. Pair of prime numbers whose difference is 2. Exactly, you are right, Swap. That's what I was explaining actually in that slide. That if you have got x square is equal to 4, anything can be. It's just a simple example, na? It can be x plus 1 the whole square is equal to 4. So x plus 1 will be equal to plus minus 2. It was just a simple example. So there is a difference between x square is equal to 4 and square root of 4. Because I have seen many students, they'll write square root of 4 to be equal to plus minus 2. That will not be true. I hope it is clear to you. So is it clear to everybody the twin prime numbers and the meaning of perfect numbers? Perfect number is a number which is equal to the sum of its proper divisors. A perfect number is a number which is equal to the sum of its proper divisors. For example, 6, for example, 28 and many other perfect numbers as well. I hope it is clear to you. So that's all we needed to discuss in the basics, the types of. Obviously, this is not a JEE session Swap. Obviously, these are the basic types of numbers. Now, in JEE, you will never get a question on the basis of basic definition of numbers, right? This is Infinity Learn class 9 and 10 YouTube channel. I hope you understand that, Swap. Hello, Deed. Welcome to this session. Okay. So, the fundamental theorem of arithmetic that every composite number can be expressed as a product of primes, and this factorization, this expression is unique apart from the order in which the prime factors occur. Every composite number can be expressed as a product of primes, and this expression or this factorization is unique apart from the order in which the prime factors occur. It means if you take a simple number, for example, I am taking 18. 18 you can prime factorize like this or not, 2 into 3 into 3, right? So this prime factorization is unique. What does it mean? That in the prime factorization of 18, 3 will come 2 times and 2 will come 1 time. That is fixed. You can never get any other prime factor over here. Apart from the order in which the prime factors occur, order can change. For example, 3 into 2 into 3 it can be written. For example, 3 into 3 into 2 it can be written, right? So every composite number can be expressed as a product of its prime factors apart from the order in which the prime factors. The proof obviously we are not doing over here, Swap. I hope you understand that. Deed, what are co-prime numbers? We have already done in the previous slide. Deed, you can please go back. Co-prime numbers are numbers having no common factor except 1, relatively prime or co-prime you can say. For example, 2 and 3 they are co-prime numbers because they are not having any common factor except 1. You got it? Or you can say their HCF is 1. I hope that is clear. So every composite number can be expressed as a product of primes apart from the order in which the prime factors occur. You can think of many other examples. Again I am saying, for example, the prime factorization of 18, 3 will come 2 times, that is fixed, 2 will come 1 time over here, that is fixed. You cannot get any other prime number, and the number of times 2 is coming and the number of times 3 is coming, that can never change. But yeah, the order can change. I mean, it can be written like this, right? I mean, there can be change over here because you know that multiplication is commutative as well as associative. I hope it is clear. I hope that is clear to everybody over here, right? Swap, which we are doing it over here. See, we are doing according to the syllabus of CBSE grade 10 mathematics, and obviously I will be taking NTSE questions and all that as well. But this is the very first session, so therefore I will be following that flow only. I hope you understand that, right? Right. Let's move on to the next thing. So suppose you have got this question, consider the number 7 raised to the power n, where n is a natural number. Check whether there is any value of n for which 7 raised to the power n, there is a mistake over here, for which 7 raised to the power n ends with the digit 0. Can you tell me? Can 7 raised to the power n, where n is a natural number, end with the digit 0? Tell that, guys. Is it possible? So it's a kind of theoretical question. It is there in NCERT only. It is one of the basic questions which you can do. NCERT question only over here, this question. So basically, when a number ends with 0, just think that. Suppose a number is ending with 0, it is having anything over here, A, B, C, D, anything it can have, right? So if it is ending with 0, what does it mean? That in the prime factorization of that number, at least one 10 must come or not. In the prime factorization of that number, at least one 10 must come up. It means in the prime factorization of that number, at least 2 into 5 must come up. It means 2 raised power 1 and 5 raised power 1 must come up. If a number is to end with at least 1 0, if suppose only 1 0, minimum 1 0 you are taking, so in the prime factorization of that number, 10 must come up at least one time. So it means 2 must come up and 5 must come up at least one time in the prime factorization of that. Now over here you see that is 7 raised to the power n. 7 is itself a prime number. So in the prime factorization of 7, you can never get 2 or 5. You can never get 2 or 5 because that is happening by the uniqueness of the fundamental theorem of arithmetic, that every prime, obviously it is, basically you can write it like this, 7 raised to the power 10, it is, you can take any natural number. Suppose you are taking 5 over here. So every time it will be 7 multiplied by itself, right? So if it is 7 multiplied by itself n times, what does it mean? It is 7 multiplied by itself n times, 7 into 7 into 7 n times, right? So by the uniqueness of the fundamental theorem of arithmetic, you can say that over here 2 will never come and 5 will never come. So if 2 will never come and 5 will never come, this will never end with the digit 0. Is it clear to everybody over here? I hope it is clear, swap. To everybody else in this session, I hope this thing is clear. Okay. So let's move on to the next thing over here. Now we need to see HCF, or highest common factor or greatest common divisor. It is the product of the smallest power of each co-prime factor in the numbers. For example, I am taking the prime factorized form of a number. Suppose it is something like this. I am taking the prime factorized form over here, right? And suppose a number is something like this. In the prime factorized form only. So we have to find the HCF of these two numbers. What will be the answer over here? So the HCF of AB will be what, guys? A and B will be what? HCF is the highest common factor over here. Yes, HCF will be what? Why 2 and 5? Because 2 into 5 is equal to 10 swap. I had discussed that already. See, again I am saying that if you want to understand. See, if a number is to end with the digit 0, just think that in your mind. If a number is to end with digit 0, so it means it is anything, something multiplied by 10 or not. If suppose only 1 0 you are talking about, obviously it can be more than 1 zeros as well. So if suppose only 1 0 you are talking about, it means at least 1 10 is there in the factorization of that number. Yes or no? So if 1 10 is there, it means 2 raised to the power 1 into 5 raised to power 1 is there in its factorization or not? Because 10 is 2 into 5. You got it or not? But if you see 7 raised to the power n, what is that? It is 7 into 7 into 7 into 7 n times. So by the uniqueness of the fundamental theorem of arithmetic, you can never get 2 and 5 over here. Will you get a 2 and a 5 in the prime factorization over here? Because every composite number can be expressed uniquely as a product of primes, apart from the order in which the prime factors occur. I hope it is clear. So you can never get a 2 or a 5 and a 5 over here because you want both 2 and 5. So you will say by the uniqueness of the fundamental theorem of arithmetic, we can never get a 2 and a 5 in the prime factorization of 7 raised to the power n. Therefore, 7 raised to the power n can never end with the digit 0. So that is the explanation of that. Now we have to find the HCF over here. So HCF is what? Just write the common factors first. So common factors are 2 and 5. Common prime factors first, only common, and then you have to write the smallest power. So 2 raised to power 3 will be coming over here, 5 raised to power 3, 5 raised to power 7. So smallest power you have to take. So that is the HCF, whatever may be the answer, but that's how you can find the HCF of two numbers. I hope it is clear. Lowest common factor. Highest common multiple you can never find, na, Deed? Highest common multiple can you ever find of two numbers? Tell me. Is it possible to find highest common multiple? It will never end, na? It will be infinite only. For two numbers, if you will find the highest common multiple, can you find that? So therefore, you find the lowest common multiple, because highest common multiple is impossible to find. You just think that in your mind. You got it? Is it clear or not? Tell me. And lowest common factor you can find as well. For example, the lowest common factor over here will be what? The lowest common factor will be 1 only. You got it or not? That is 1 only, na? That's what I am saying. Deed, highest common multiple you can never find. You got it or not? Highest common multiple you can never find. A lowest common factor which you are saying, that will be 1 only. So what is there to find in that case? I hope that doubt is clear, Deed. Is it clear to you? Is it clear that lowest common factor is 1 only and highest common multiple you can never be able to find? So therefore you never do that. I hope this is clear to everybody, how to find the HCF of two numbers. Right? Now you see over here LCM, how do you find? Suppose I take any number over here. Suppose A is equal to, in the prime factorized form only I am taking. Suppose it is something like that, you have to find the lowest common multiple. So the LCM of these numbers will be what? You have to include all the prime factors involved. All the prime factors involved in both of them. For example, this is 2, 3, 7 and 13. You have to include all the prime factors involved in both of the numbers over here. I hope that is clear. And then you have to take the highest power of it. 2 raised to the power 5 and see 3 raised to the power 5, and obviously it will be 7 raised to the power 8 and 13 square. So this is the LCM of these two numbers. I hope it is clear. Any doubt in this thing? I hope your doubt is also clear, Deed. And I hope it is clear that how to find LCM and HCF of two numbers. Highest common factor, which you call greatest common divisor as well, and the least common multiple or the lowest common multiple of two numbers. It's a very basic thing which you have been studying since childhood. So let us do some questions on LCM and HCF over here. So if two positive numbers A and B are written as this and this, where X and Y are prime numbers, the result obtained by dividing the product of the positive integers by LCM is what? Okay, wait, before this, let us do one more question over here. Wait, let me see that. Maybe we will not be able to do this question right now. Okay, so before that you can do this question first. Can you tell the answer to this one? The ratio of the LCM and HCF of the least composite and the least prime numbers is? Ratio of the LCM and HCF of the least composite and the least prime number. Because that is the definition of square root. We call it principal square root. I hope you understand that swap. Square root of x square, basically you see this is the definition. Square root of x square is equal to modulus of x. You don't have to take negative out of it. You got it? Even if suppose you have got something like this, square root of root 2 minus root 3 the whole square swap. I hope it is clear. So if you will say it is root 2 minus root 3, that is not correct. This is wrong. Because square root of x square is equal to modulus of x, so you have to take its positives, you have to take its modulus only. You got it? So that will be modulus of root 2 minus root 3 over here. And because this is a negative value, you will get root 3 minus root 2 only. I hope that is clear to you. Now the ratio of the LCM and HCF of the least composite number. So what is the least composite number over here? Least composite number is 4 and the least prime number is 2. So you have to find the LCM, ratio of LCM and HCF. So LCM is what? LCM of 4 and 2 is 4 only. And what is the HCF of 4 and 2, guys? HCF is the highest common factor, so the HCF will be 2 only. So basically you have to find the ratio of them. Ratio of 4 and 2 you have to find. I hope it is clear. So the ratio is 2 upon 1. In the ratio form it is 2:1 only. Is it clear to everybody over here? Option B is correct. Deed, I hope it is clear. Swap, I hope your doubt is clear to you. Right? I hope it is clear. That is the definition of its swap. Square roots definition is that. You understand the meaning of definition of something. That logic is not working over here. That's what I am saying. Square root of x square is modulus of x. That is its definition. I have taken one example over here. Square root of root 2 minus root 3 the whole square. You cannot say it is root 2 minus root 3. It will be wrong. You have to take modulus of that. I hope it is clear to you. So option B is correct over here. So let's move on to the next thing over here. So the LCM of two prime numbers is P and Q, where P is greater than Q is 437. Can you find the value of 2P minus Q over here? LCM of two prime numbers P and Q is 437. Can you find the value of 2P minus Q over here? So LCM of prime numbers is what? It is the multiple of product of those two numbers only. Just think that. So what is 437? If you do its prime factorization, what is coming out over here, guys? So basically 437 is equal to 19 into 23. You got it or not? So the product of these two numbers is 437, and as they are prime numbers, so this is nothing but their LCM as well. You got it or not? This is nothing but their LCM as well. So 19 into 23 is nothing but P into Q over here, and it is given that P is greater than Q. So there is no other possibility but to take P is equal to 23 and Q is equal to 19. Is it clear? So P is equal to 23 over here. Bad bro, we are doing over here mathematics. I hope it is okay with you. कोई जोक सुनाइए. चलो ठीक है, यहाँ पर क्लियर है सबको. So P is equal to 23 and Q is equal to 19 over here. We have to find the value of 2P minus Q. So 2P minus Q will be what over here, guys? 2 into 23 minus 19. So that is equal to what? 46 minus 19. 46 minus 19, and what is that equal to, guys? 27. 27 is the answer. I hope it is clear to every student. Correct, that is okay. Yes, Pradeep, that is correct. I hope it is clear to every student in this session. Let's move on to the next thing. That is called the principal square root swap. I am saying that that is the definition of that. That is principal square root. You take the positive value of that. I hope you understand that. And I hope if you are there in grade 10 mathematics, please do this. Please concentrate on this thing. That is called principal square root. Okay. I hope you understand that. Okay. Let's move on to the next thing. And can you do this question, guys, over here? Hello Ashutosh, welcome to this session. So over here A and B be two positive integers such that A is equal to this, B is equal to this, where P and Q are prime numbers. So if HCF is this and LCM is this, then you have to find M plus N into R plus S over here. So it is already given that PQ and RS, they are prime numbers. So what will be the HCF of these numbers? Just see it, guys. Just if you see what is the HCF. HCF is the highest common factor. So you have to take the common factors first, P and Q, and then you have to take the least power. So P square it is, so take P square, and you see Q cube, so you see it is 3 over here. Now what is the LCM of them? LCM is the least common factor. Obviously you have to take the prime factors involved in both of them, and you have to take the highest power of it. So you see Q raised to the power 4 I will take, and P cube I will take, right? So this is the HCF and this is the LCM. You have to find the value of M plus N, R plus S. Now HCF is this Mn over here. You see P raised power M, Q raised power N. So M plus N is what? 2 plus 3 over here. And R plus H is what? Because LCM is P raised power R, Q raised power S, and we have got LCM to be this. So LCM will be equal to 3 plus 4 over here. So what is this equal to? 5 into 7 and that is equal to 35. So this is the answer. I hope this is clear to every student over here. It is coming out to be 35, guys, just check it. It's coming out to be 35 over here. Right. I hope it is clear to every student over here. Hello Manved, welcome to this session. Any doubt in this question to any student over here, guys? Chalo. Swap, you see, you can find the HCF. How you can find? These are prime factors over here. P and Q are prime factors. So their HCF will be what? Highest common factors. You have to take the common prime factors, and then you have to take the least power, right? P square, P cube is there, so P square you will take. Q cube, Q raised by 4 is there, so you have to take Q cube over here. Now if you want to find the LCM, then obviously you have to take the prime factors involved in both of them, that is P and Q. Now you have to take the highest power. P cube, P square is there, so P cube. Q raised by 4, Q raised by cube is there, 3 is there, so you have to take 4 over here. Now if you compare this HCF with this P raised by m, Q raised by n, so m plus n will be 2 plus 3 over here. And if you compare LCM over here, so R plus S is 3 plus 4 over here. So this is 5 into 7, so that is 35. I hope that is clear to every student over here. Chalo, okay Akshay. I hope that is clear to everybody in this session. Now you see, actually some of the questions I'll take in the next session over here, right? One concept I'm explaining to you, and then in the next session I'll be taking some more questions which are left over there. First, this concept I'm explaining, this is a simple concept. The LCM and HCF of two numbers, LCM and HCF of two numbers is the product of the numbers itself. LCM of AB and HCF of AB over here, that is equal to the product of the numbers itself, right? LCM of two numbers and the HCF of two numbers is the product of the numbers itself. I hope it is clear to you, right? Okay. I hope it is clear. It will be there on the Infinity Learn class 9 and 10 YouTube channel, Akshay, and the schedule will be shared with you on the Telegram channel as well. Please subscribe to the Telegram channel as well. I hope that is okay with you, right? Okay, so the product of two numbers is the product of the LCM and HCF, and it's not going to happen for any number of numbers. It's not that it's going to happen for 3 numbers as well. There is a different formula for 3 numbers. I hope it is clear to you. A simple question you can do over here: if LCM of x and 18 is this and HCF of them is given, you have to find the value of x over here. Okay. So LCM is given and HCF is given. So basically product of the numbers, that is x into 18, is equal to the product of their LCM and the HCF over here. So from here you can find the value of x. So x will come out to be equal to 4. So that is the answer. I hope that question is clear to every student over here. It's a simple question. 4 is coming out to be correct. Product of the two numbers is equal to the product of their HCF and LCM over here. Now some questions are left, some important questions are left. I'll take them up in the next session, right? Because not much time was left, therefore I'm not explaining that concept. So in the next session, we are going to do other things in this chapter, that is proofs of irrationality, and also we'll be doing some left out questions over here. So that's all we needed to do in this session, guys. Don't forget to like, share and subscribe to the Infinity Learn class 9 and 10 YouTube channel, and don't forget to subscribe to the Telegram channel as well, so that you can get this schedule, because in the Infinity Learn class 9 and 10 YouTube channel, we are conducting Pratham series for grade 9 students and Pioneer series for grade 10 students. Bye bye guys, see you then in the next class. Take care everybody.